Hello, and thank you for joining me for this guided project on ensemble methods. We're going to do an early stage diabetes prediction. Okay, so you can use the link to find the data set here or the original data set on Kaggle. Link to my a group of the Art of Data Science sharing some awesome data analysis plots and stuff, and mounting my drive, importing libraries, and today we're going to work with just a few pre-processing, decomposition, and train test split from sklearn, and then we're going to work with random forest bagging classifier, gradient boosting, and adaboost. Okay, so we'll do that one. The data set is available. I also have it. You can get it from the website, or I have it and it's exactly the same, or I have it on my GitHub repository. So you just download it using this URL. You don't need to actually go and download the CSV if you should not want to. So you just assign it to URL. What we're going to do here is read_CSV, and you'll actually notice that at the end of this is a CSV file. So you can actually go into the file on your GitHub and go to the raw site, and this will give you basically a CSV file. So you can then just use pandas.readcsv to load it up. And what we'll do here, the first one, so pandas.readcsv equals df. We'll do another one here, df equals head, or sorry, df.head, parentheses. We'll look at the head of the data set. Another really important thing, just to understand how many rows and how many columns, we'll go df.shape. Look at it there, 520 rows, 17 columns. Another really important thing as we head into the EDA section, and I do consider this part of the EDA, this is really inspecting the data types. If you're not familiar how important they are, I promise you they're very important. They're annoyingly important. So it's always good to kind of start off checking, making sure so you have a good understanding of what you'll be able to do with each column, or if there's errors to correct. And so here we have all objects, we have one integer, and so just be aware of this, everything is a category today. So what we'll do here is we'll do a little for loop, and I've left, I'm a really nice teacher, so I've left most of this for you so we can practice just the plotting functions today. So we'll go for feet in df columns. This is going to loop through or iterate through the list that is produced from df.com. So list of all the column names. We'll take each column name. We'll make sure if the integer type is, if the data type is an integer, we're going to do one type of plot. This one, if we take a look right here, age, we're going to do a distribution plot. And then if it is else, so if it's an object, the other thing is an object, we're going to do a count plot. So what we'll do here is in place of the none, and we can get rid of the comment signs as well, we'll do sns.histplot, data equals, oops, get rid of that one parentheses, data equals df, and x equals feet. So our feature, so actually it was the name of our feature every time. So we're giving our whole data frame to Seaboard, and then we're going to just select out which column we want to process it on the x-axis, which is only going to be, in this situation, the age column. So and the next one we'll do sns.count plot, and we'll go data equals df. X equals feet, and get rid of these two colons, or sorry, comment signs right there. So we'll run this, and we'll actually see one other place, so we don't forget this, is we're going to change the title to bold stylized. So we actually go font weight to change that. And so we look at this and we'll run, we get a nice little plot, and just, I think it's nice to make this a little bit bolder just to kind of make sure they stand out without have to make them too big. So there, we're going through there, and I have all these observations. I recommend going through them and reading them. Really make sure you understand why I'm saying what I'm saying. I also would admit that I'm as general as possible, or sorry, I'm as to the point as possible, not as general, the opposite of as general. Just to be as blunt, so you can use these later on in your to-do list for your pre-processing, so you don't have to reanalyze all the graphics. So writing short form notes, even to yourself, is very valuable, and that's kind of what I've done here. And pointing out that our target has a moderate imbalance, and the most represented is the positive class. So if we were concerned in building a model that predicts the negative class, this model we would want to resample kind of the distributions of our data that would reflect kind of focusing on, which class was important to us. So here what we're going to do is we're going to do a little bit different. We're going to do bivariate analysis. We're going to look at the univariate distribution, but we're going to separate it by the class, the target, to kind of get a sense of how these distributions are related to the target, which could relate to how we end up pre-processing data. So we're going to go S and S in the place here. So we're doing the same thing, 4 feet in df columns. So it's going to list of the column names. We're going to check the data type. If it's an integer, we'll do one type of plot, do a hist plot. And then if it's else, which is everything else, which is only objects in this case, so we're going to do SNS dot count plot. So literally the same thing we did above. The big thing here that we're doing differently is we're giving it the hue argument class, and we're giving it the palette, the 2 colors, there's 2 classes. So just to make it a little bit more interesting, and this is really just a really valuable way, use case of Seaborn is using the hue to inspect by a different category or by the target, which in this case the target is very, very helpful. So just plotting all those. And here we go. So quite a few plots. Next, heading into the pre-processing section, it's always a good idea to look at the null values in this situation. So is null, so df.isNull parentheses dot sum parentheses, and here we go, we have no null values, which makes the pre-processing easier today. We do have some outliers in the age column. We only have one continuous distribution, so we have some outliers here. So the way that we'll fix this is we're going to go the age column equals the age column, so df square brackets age dot clip, and then we'll set the lower side to 24 to move it in so it's still on the edge, but it's not so extremely on the edge, and upper moving that to 76 here. So you can see this one, and we can see, let's take a look at this right here, and we're looking at the, it's just the same as up here, so we can actually just copy and paste it. We want to be lazy and put that in right here, because professional coding is really about copying and pasting as much as possible. Not other people's, but your own code is totally fine, right? So hist, and we can see now we got rid of the outliers. Going into one-hot encoding, so it's like to create a list of the names of the columns. So this is the list that we've looped through up above, and here what we're going to do is do .info, and we want to do all of the ones except for age. So I copy this list right here, and I put it here, get rid of the age, and then I also don't want the class. We just want to deal with the features today. And so going through that list, I'm then going to go in the next column here. We'll go pd.get underscore dummies df columns equals features cat. It's features cat. Okay, and so we'll do that, and it will return a new data frame with the one-hot encoded features. And we can see if we look at the shape, get 32, and then just inspecting the head to see and confirm that it works like we wanted it to work. So you can see the one-hot encoded values here, and the age column is left as is. Okay, going to the modeling section now. So we'll go df.columns. I like to always create a list of the features that go in, so I can unselect some of them. Unless I don't want to look, I want to see how my model performs without this one feature, or as many as I decide. This allows for the experimental process, and I really recommend kind of keeping this list. This is, again, a personal style preference, but this is it's just really allows for the idea of setting up experiments, and really data science is an experimental science. So here what we're going to do, we have a list of our features. We're going to go df features, and that equals our features. We'll go df target, and that equals our x and our y values right here. I'm just going to short form this. I really like this style now. It's really just a little bit easier to workflow. So we'll go x for our train test split down below this after we make sure we run these before, and then we'll get our x's assigned to x. And to do our train test split, we'll go x tr x ts y tr y. So x train, x test, y test, y train, y test. And so train test split, give it all of our x values. We're going to do a 30% train test split. we'll call standard scalar next, and we'll might as well just fit this right as we call it. So we'll go dot fit, and we'll fit it to the X train value. So we'll run that, and then we're going to do PCA, so principal components, which really just standard deviation, standard scalar really adds like maybe I would say 10%, 15% extra or better score. And PCA not quite as much, but it still performs your score maybe 5 to 10%. So it is really always worth doing. You do lose kind of the understandability of what your data is once you perform this transformation, but it is really valuable. So we'll do the same thing. We'll go PCA.fit, and we'll give it our X train value, and we'll run this column. So X train, I have the left, so PCA.transform, same thing here, standard scalar.transform to transform our values after we fit it. Going to the next one, we're going to build a little model, a little function model factory to get our scores from our model. So we're going to pass this X train, X test, Y train, Y test, and our model, just to get the function initialized, is none, or we'll pass it a different model each time. So when we take in our model, we're going to fit it, and then we're going to get the scores from our model. So replacing the nuns here, we'll go model.score train and get our train score. We'll do model.test or .score and get our test scores. And so run this function, and then we'll be returning model score train score test. And so here we'll do in the down, we'll start running our random forest section. So we'll go random forest classifier, and so we'll run that, and then we're going to send it to RF, and then we're going to give our function RF because we set our defaults to be train and test split already. So here we'll do the next one is we'll do bagging, spell that properly, bagging classifier. So we'll run that. We're going to call that bag, and then we're going to assign model equals bag in our model factory function. Bagging classifier. Oop, I have two G's here, guys. Gotta spell your words right. Okay, let's go. Let's see how I spelled that. Bagging classifier. I don't know how to spell bagging classifier. So when you have those brain fart moments, and you can just go up and copy how you imported it, because it obviously worked correctly up above. So and it works well here now. So do the next one on adaptive boost classifier. And then call this one, we're going to assign this to ADA, and then model ADA, and get our train models and our score and our train score. And I spelled that wrong, classifier. Really bad at spelling today. Good when you're making a YouTube video to be a bad speller. Oh, super bad. And so adaboost. Truthfully, I forget this one a lot, and this is why it's good not to copy and paste, because you end up forgetting what the models are called. And so calling this one, the next one we're going to do gradient boosting. This is my favorite model, gradient boosting classifier. Gradient boosting classifier. Oops, I spelled classifier wrong. Classifier. Perfect, there we go. So we do that, and we get our train and test scores for each one of those. We'll then assign them to lists down below. We'll send a list of our models down as well to make our index values in a data frame just to inspect these scores. We'll then go train. We're going to make a dictionary. So the key is train score, and the value is train score. So the list up above that we've made, because the key essentially ends up becoming our column title. So here, column title, and this is the values inside, column title, test scores, values inside, and then we're going to assign to a data frame our dict scores. And there we go. Get a look at our scores. Oop, train score. Oop. Forgot I was doing the short form, doing the long form. Like I'm not lazy. And then here we go. And we can see here, our random forest did the best, and gradient boosted the second best. And they all did actually quite well just with the standard default settings. We can always experiment with different hyperparameters. But in this situation, we actually did quite well on the test score. our train score I would have thought was overfitting, but because our test scores really aren't, we would want to maybe see if we could reduce this train score a bit, and have it maybe 0.97 and a test score of 0.97 or 0.98 and 0.98 sort of thing. Because there might still be a little bit of overfitting that we could inspect, but pretty good with default parameters in our models. So thank you for joining me on this hyper awesome guided project, and I will see you for the next one. Bye.